lab 4, Oscillations by Chico and Banu. So in this lab, I examine the motion of an object that is oscillating on a spring while swinging in an arc. Then I use Tracker to get the position data and use that data to create a model in GlowScript. And so the fundamental principles that I used in this lab were the momentum principle, which the formulas I have on the screen. I also used the several forces, including the spring force and the gravitational force, which I also have the equations for. And then we use the energy principle and the conservation of energy, which states that delta E is equal to 0. And in this lab, the forms of energy we had were kinetic energy and potential energy. And for potential energy, we had spring energy as well as gravitational potential energy. For my initial conditions, we had a mass of 0.402 kilograms. And then using the data I got from Tracker, I was able to calculate the spring constant using that K is equal to 4 pi squared times mass over T squared. And so I had a T of 1.519 seconds. And so using that, I got a spring constant of 6.878 newtons per meters. And so then the initial velocity was 0 meters per second in all directions. And my initial position was negative 0.112 in the x and negative 0.629 in the y, and then 0 in the z direction. And then I got a relaxed length of the spring of 0.127 meters, and I used this formula that was given to us in the lab video. And then our delta t was 1 over 210 seconds. And on the right, you can see where I plugged all the information into my GlowScript code. Now this is my model and tracker, so you can see the axis that I use to track the motion, as well as looking at on the right, you can see the graph that I got and the table values that I got for my motion data. And then this is the information that I put into GlowScript. So in the first arrow on the left, you can just see where I specified L, L hat, and S for the spring. And then next, I specified all the equations for the different types of energy I had, which was kinetic, gravitational potential, and spring potential energy, and then as well as the total energy formula. Then next line, I defined the initial energies, and then on the left, you can see where I plugged in all the formulas and equations to calculate the forces, as well as updating the object's velocity and position, as well as updating the spring and calculating my energy changes. This is the graph I got for change in energy versus time using my GlowScript code. The blue line corresponds to the change in kinetic energy. Green is for the change in spring potential energy. Red corresponds to the change in gravitational potential energy. And orange is the total change in energy. And so my graph is consistent with the energy principles because the total energy change is always equal to 0. This is the graph I got for position versus time using my computational model. The red line corresponds to the observed motion I got from Tracker, whereas blue corresponds to the predicted motion from my GlowScript code. And so in this case, both graphs line up pretty well. However, the computational model overpredicts the position. This could be due to errors in getting the position data from Tracker because it was hard to get the exact center of mass of the object, or this could also be due to effects from drag force that weren't included in my model. Question: in my model, is the energy principle satisfied? Yes, the energy principle is satisfied in my model, and I know this because looking at the graphs on the energy versus time, I can see that the orange line, which represents delta E, the total change in energy, is equal to 0 at all time points. The total energy does not increase or decrease, and so this satisfies the energy principle, which states that delta E is equal to 0. And then comparing the estimates of oscillation periods, for the x, I got an average t of 1.519 seconds. In the y, I got an average t of 1.424 seconds. And so the time period was shorter in the y direction. And this is because the oscillation on the y is more accurate because the forces are acting on the object in the y position. And so in conclusion, this model obeys the energy principle and is a good model of a spring mass system.